Welcome to Routing Essentials. This is going to be dealing with Chapter 5, Inter-VLAN Routing. Alright, so what is Inter-VLAN routing? Inter-VLAN routing is going to be the routing between VLANs. And a big part of that is going to be dealing with how to configure it, how to troubleshoot it, as well as what are some Layer 3 switching technologies. Our objectives are to describe the options for VLAN routing, to configure legacy, to configure router on a stick, troubleshoot, and configuring VLAN routing on a Layer 3 device. Lastly, troubleshooting inter-VLAN communication on a Layer 3 device. Alright, so inter-VLAN routing. That is going to be communicating between VLANs. So it has to go up to some type of Layer 3 device. Here we have a router, a switch, and two PCs. The PCs are in different VLANs. So this PC is in VLAN 10. It's going to travel up the switch and through a dedicated port or a dedicated access line to the router. That's all going to be VLAN 10. Router will then process it, retag it, and then send it down the VLAN 30 link through the VLAN 30 link all the way down to PC3. That is a legacy technology. Layer 2 switches cannot forward between different VLANs without a Layer 3 device. In the past, actually, routers were used to route between VLANs. Each VLAN was connected to a different physical interface on a Layer 3 device. Normally a router, but that's not the only Layer 3 device out there. Because the router interfaces were connected to VLANs and had IP addresses from specific VLANs, routing between VLANs was achieved. The larger the network grew, the more requirements, the more complex. Router on a stick uses a different pathway. What it does is it allows for us to use a trunk and then to configure a 802.1q trunk port so that we could set a bridge, a pathway between our router and our switch so that we would have one link for all VLANs to travel through. And what would happen is each VLAN would be stamped appropriately with that 802.1q tag. VLAN members or hosts were configured a specific exit on the router, known as a sub-interface. And that sub-interface would act as its default gateway. It would be a virtual interface on the router. Only one of the router's physical interfaces were used. What about if we have multi-layer switches? And how does that affect inter-VLAN routing? Multiple switches can perform Layer 2 and Layer 3 functions. So, again, we're going to get rid of a Layer 3 device, no longer tying it to a router, but another Layer 3 device, a Layer 3 switch in this regard. Multi-layer switches support dynamic routing and inter-VLAN routing internally on the switch because it's a Layer 3 device. The multi-layer switches have to have an IP address. They have to have a virtual switched interface, also known as a switched virtual interface. The switch would understand a network layer PDU. So that would be a layer 3 packet. Therefore, it could route between the switched virtual interfaces, just as a router would do. With a multi-layer switch, traffic is routed internal on the switch. This routing process is suitable and a scalable solution, no longer being tied directly to a Layer 3 router. Or to a router, because a router is a Layer 3, but you could have other Layer 3 devices handling it. So preparation. Legacy Inter-VLAN routing requires routers. That means you have to have a physical interface per route or per link for a connection. Each one of those routers' physical interfaces is connected to a unique VLAN. That's just retarded. Each interface is also configured with an IP address. Example, these links are all VLAN 10. These links are all VLAN 30. That's not a great idea, but that was an old way. How we did that is, we would create the VLANs first. VLAN 10 created VLAN 10. VLAN 30 created VLAN 30. Then we would navigate to each interface, and we would hard-code it switch port access VLAN 10. That was one way of doing this. On the router, we would assign an IP address to each of those physical interfaces. That way, this IP address would be for VLAN 10. This IP address would be for VLAN 30. This was a really bad way of doing it, but this was one way. So the preparation for router on a stick. This allowed for us to use a trunk, not having a unique interface. This would force us to have sub-interfaces. Here is VLAN 10, here's VLAN 30, and there would be a trunk between S1 and the router. On the router, we would have a sub-interface. Since it's physically plugged into G00, we would use a sub-interface G0/0.10. That would allow us to use the sub-interface .10. On the switch, all you'd have to do is configure the switch port for that connection to be a trunk. That's it. On the router side, you'd have to set the sub-interfaces correctly, assign an IP address, and encapsulate it. An example would be interface G0/0.10. That created the .10 subinterface. We would encapsulate it using encapsulate.1q. Next would be what VLAN is allowed on that subinterface. That would be the 10 VLAN. Afterwards, assign it an IP address and a no shutdown. That's it. You go on to the next one. Interface G0/0.30. Do the encapsulate.1q. What VLAN is it? .30, or it's VLAN 30. Assign an IP address, no shutdown. At the very end, make sure to turn on the parent interface. You notice they're all part of G0/0. Make sure G/0 is turned on. So do a no shutdown there. That's it. Sub-interfaces configured, Inter-VLAN connections, good to go. Inter-VLAN routing is pretty simple with router on a stick. You have to remember, create the sub-interfaces, encapsulate, use the appropriate .1q, whatever VLAN they're in, turn on the parent interface. That's it. So how do we verify? You could do a show VLAN. You could see which VLANs are associated with it. You could see which lines are tied to trunks. Show VLANs on the router will actually show you the trunks. Show IP route on the router will show the sub-interfaces, both directly connected and a linked local address. So, how can we verify? You can ping. Try pinging between the two PCs now, PC1 to PC3. They're on different VLAN, but as long as those virtual interfaces are correctly configured on the router, again also known as sub-interfaces, you are good to go. So let's start talking about how to troubleshoot VLAN, inter-VLAN routing. The first thing you have to realize is, did you appropriately assign the individual ports to the appropriate VLAN? Don't forget switch port mode access. switch port access VLAN, what VLAN? Those have to be done under the appropriate interface because you're going to configure each interface. After you're done with that, have you set up the switch port? Have you set up the trunk port on the switch? So navigate to whatever port is going to be the trunk. Make sure you're underneath the appropriate interface. Switch port mode trunk. That's it. Verify. Show interface, what interface, and switch port. That will tell you, what is it? Is it a trunk? Is it not a trunk? Is it encapsulating? What version is it encapsulating? It's going to let you know. So verifying router configuration. Hop on the router. Show interface. Again, the appropriate commands here. Create the sub-interfaces. Once you created the sub-interfaces, do the encapsulation.1q with the appropriate VLAN. Give it an IP address. Turn on the parent interface. That's it. You're good to go. How can we verify? Do a show interface. You could go through all of the interfaces and you can see the encapsulation. You can see where their VLAN, where their trunks, where their access lines. Other common issues? Are the appropriate IP addresses set? Are the appropriate IP addresses for the sub-interfaces correct? Are the default gateways set? They're the common mistakes. Make sure you can do show IP interface, show IP interface brief. So you could be looking at the IP interfaces. You could be looking at if they're up, if they're down. You could also do a show run. So you could see the running configuration all the way through. Alright, let's go ahead and move on to layer 3 switching. The next section is all about our routed ports versus our switched ports. Layer 3 switches usually have packet switching throughput in the form of millions of packets per second, PPS, packets per second. All Catalyst multi-layer switches support the following types of layer 3 interfaces. A routed port, i.e. a layer 3 port, versus a switched virtual interface, SVI. They also accept a switch port. That is going to be a port that you tell is a switch port that will mimic a layer 2 port. Some of the higher level switches could be a Catalyst 6500 series switch. I actually have 2 in my possession right now. Or it could be a Catalyst 4500 series. These are all capable of acting like a layer 3 device. A Catalyst 6500, most people are not going to be able to get a hold on. They're fairly expensive. They're nice, but expensive. Several other models of Catalyst switches do have specific routing protocols. You just have to figure out which ones you have and if they support them. Inter-VLAN routing on those SVIs. Today, routing has become fast and cheap. And so those hardwares have to become fast and cheap. Routing can be transformed or transferred to the core and distribution layers without impact. Many users are in separate VLANs. They still need to have access to the appropriate resources that they need. Layer 3 routed ports are normally implemented between the distribution and core layer. This model is less dependent on spanning tree, and that means no loops, no black holes. Meaning we're getting rid of a lot of layer 2 device ports. So by default, a switched virtual interface is created for the appropriate VLAN, the default VLAN, which is VLAN 1. You can treat this like a virtual port or a port on the switch. You do that by interface VLAN 10 or VLAN 1, and that would create a virtual interface. Here, if we wanted to create a virtual interface for VLAN 10, it is literally just interface VLAN 10. That would create a switched virtual interface named virtual or VLAN 10. It's virtual, it's not physical. You would have to associate it with a data frame. So you have to give it an appropriate VLAN. So encapsulate what VLAN. When the switched virtual interface is created, ensure that the specific VLAN is present in the VLAN database. Make sure to set the virtual interface to the appropriate VLAN. That's critical. This is where most people mess up. Advantages. Router on a stick becomes a lot easier. No longer having to deal with multiple connections. No longer having to deal with a layer 3 router or router. Not limited to one link, meaning layer 2 ether channel can be used, or a link aggregation protocol, LAX, could be used. A router's port is a physical port that acts similar to an interface, but is on a switch, a routed port. Think of that as just a layer 3 port. Layer 2 ports, such as spanning tree protocol or STP, do not function on a layer 3 port. Again, that is how we tell a switch port what layer you're on. Switch port tells it layer 2. No switch port turns it back to layer 3 or a routed port. A specialized note, routed ports are not normally supported on lower switches like a 2960. Cisco does have a switch database manager, SDM, which provides multiple templates for 2960s. So you could do an SDM LAN-based routing template, which would could be enabled to allow switches to route between VLANs. That way, it's not really a switch port interface. It's a workaround for the 2960s. You could view them by doing a show SDM prefer, so you could see what templates are part of the switch database manager. Again, that's not normally preferred. You normally want to do switched virtual interfaces on layer 3 devices. Trying to get a layer 2 device to do it, possible, not the best solution. So, configuration issues, last thing to cover. VLANs. VLANs must be defined across all switches. That way, if you're doing VLAN 2, make sure VLAN 2 is on all the switches across the VLAN, or across all switches. Make sure the appropriate VLAN is defined on all switches. Next, VLANs must be enabled on the trunk ports. When you do your trunk ports, make sure you're allowing access for the VLANs. Ports must be in the correct VLAN. That's a huge troubleshooting issue. You program VLAN for interface 1. But in reality, you meant to do it for VLAN 1, but on port 11. Make sure you're doing the correct ports and assigning them to the correct VLANs. For the switched virtual interfaces, they have to have the correct IP and correct subnet. They must be turned on. They must match the VLAN number that they're in. For routing, routing must be enabled on our layer 3 switches. Each interface or network should be added to the routing protocol. Hosts. You have to make sure that each host is on the correct subnet, that they have the correct IP, subnet, default gateway. They have the appropriate VLAN information, and they're plugged into the appropriate port on the switch that is the correct VLAN. So that's actually it for this chapter. There's a lot of good information, but this is actually a more trickier chapter. So if you have any questions or comments, please let me know. Thank you very much.